we've got variable acceleration here, clearly because a is dependent on time. So let's just remind ourselves, if we've got the displacement vector, then we will differentiate to get the velocity, because it's the rate of change of displacement with respect to time. If we want to go to a, we'll differentiate again, because the acceleration is the rate of change of velocity with respect to time. Therefore, if we're going the opposite way, we'll integrate with respect to t. And we're going to be doing both in this question. So because we're given the acceleration, and then we're asked or given some information on the velocity, so when t equals 0, v is equal to 36i. Find the velocity of p when t equals 4. I need to integrate. V is going to be the integral of a, which I'm going to write as 1 minus 4t, 3 minus t squared. This gives t minus 2t squared and 3t minus 1/3 t cubed, plus an arbitrary constant c. And we know when t is 0, the velocity is 36i. So that means I can write down 36, 0 is going to equal c, actually, and I'm sorted. So then it's going to be 36 plus t minus 2t squared and 3t minus 1/3 t cubed. That is my general velocity. Right, just finally, they've asked us to sub in t equals 4. So when t equals 4, b, just sub it straight into your calculator, we actually get 8 and minus 28 over 3. For b, we're asked to find the value of t at the instant when p is moving in a direction perpendicular to I. So if I've got my axes here, x and y, I is in the direction of x, so if it's perpendicular, we're looking for it to be in the direction of j, or in the direction of y. So what we can do is we can take our velocity, which we have here, and actually just set the x component equal to 0. Or you could write that, like just to guide us, we could write 36 plus t minus 2t squared, 3t minus 1/3 t cubed. But because it's in the j direction, we could write down that it's going to be 0k, for example. But from that, we can see that the top is 0. So 2t squared minus t minus 36 equals 0. I've just rearranged it to make the 2t squared, like to make it positive, and then solve it. It does factorize. So 2t minus 9 times t plus 4 equals 0. T is 9 over 2 or minus 4. Reject this one because it's negative. T equals 9 over 2 or 4.5. Finally, at time t seconds, where t is greater than equal to 0, a different particle q, so this is a completely separate part of the question, move so its position vector r relative to a fixed origin is given by this. And we're asked to find the value of t at the instant when the speed is 5. So now I've been integrating, but now I need to differentiate. So v is going to be dr by dt. I'm going to get 2t minus 1 for my I component and just 3 for my j component. That's my velocity. So now if I want to find the speed, then I can use Pythagoras' theorem, because I've essentially got a little triangle here. I'm going along 2t, I mean, I'm up against the left, it doesn't really matter though, but along 2t minus 1 and up 3. This here is the speed, the magnitude of the hypotenuse. So it's going to be 2t minus 1 squared plus 3 squared square rooted, and that's going to equal 5. So we can just square it and undo everything. 2t minus 1 squared plus 9 is going to equal 25. You could have gone straight there. I'm just trying to explain it carefully. You can expand it and solve the quadratic, but it's in completed square form, so we just don't need to. We can keep it as 2t minus 1 all squared minus the 9 to give 16. So 2t minus 1 is going to be plus or minus 4. I'm going to square roots. I can immediately reject the minus 4 because I'd get a negative time then. So 2t is going to be 4 plus 1 is going to be 5, and t is 5 over 2, or 2.5 seconds. You don't have to, I never write the units down just because it's implied we're working in SI units, but you can if you want. Anyway, we've dealt with this question really well. Well done.